This meeting is being recorded.
Greetings to everybody from sunny Idaho. I'm in Caldwell, Idaho, which is about half an hour from Boise, up 84. And in case you were wondering, this background that you see behind me was actually a sunset from I can see from my front window about a week ago. And it's sunny almost every day here, which is really cool. You know, I'm a native Puget Sounder, and I'm kind of accustomed to the gray, dreary cloudiness that we tend to have through this time of the year, and it's kind of refreshing to wake up every day and there's another sunny day, and the sunsets here are gorgeous. We sit up on a ridge where we overlook the city of Caldwell, kind of mainly off to the west and southwest of us. And this view here is just kind of a later evening, kind of looking a little bit to the northwest. So if I had my camera turned around so you could see behind me, you could actually see this view. So anyway, got myself set up here, and we're getting settled in. One of the reasons that I put this virtual background up is because there's boxes all behind me here, so I was like, it's not the prettiest background. So I much prefer this background to what's actually behind me. In a few weeks, hopefully I'll be able to get some more of these boxes cleared out of here, and it'll be a little bit more attractive. So anyway, welcome to the November meeting of the Seattle Robotics Society. I'm glad you guys jumped on here to join us. And let's see here. Whoops! No, get back out of there. Okay, let me get back where I belong. Okay, there we go. Okay, we're going to follow the usual agenda, and so there you go. We'll get into the details of this thing here as we go. If you are not actively sharing, please mute your microphones, just so we won't have the weird outbursts and screen switching and all that weird stuff. Oh, let's see. I guess I should let me turn on chat here. So in case somebody throws a question up there, watch out. Your finger and toe webs are going to dry out. Yeah, you're probably right, Terry. I can kind of feel things, my hands are starting to get kind of crunchy from the lack of moisture over here. So I can definitely see that happening. I've been having discussions with my former neighbor from Federal Way about all the different ways that you prepare potatoes over here, because of course we were talking about potato pudding this morning, and most people think that mashed potatoes are like a thing, but it's actually that's Idaho potato pudding. So. And let's see. Yeah, you're going to get spudly. Yes, indeed. Yes, indeed. Savory or sweet pudding? Well, you got a choice. You can you throw a little syrup or some fresh fruit on top of there, and you turn those potatoes into something sweet and tasty. Probably all kinds of interesting things you could do with different kinds of gravy. So. Let's see. We are, we're continuing with the online meetings for now. I have been really busy, so I apologize for not reaching out. What we have to do is reach out to Eric Van Buren, who is he's the manager at the field house, the first field house, and we could see if there's some way to get in there. I'm not certain. I'm guessing that Lloyd will probably be running the meetings in person, since it's a little bit of a drive for me, about 500 miles. So I will not be able to attend in person with you guys, but would love to be able to dial in this way. So anyway, we will we're kind of figuring we wouldn't start probably until sometime next year, and we'll just kind of see timing wise how that works out. So oh shoot, I should have updated this slide too. I mentioned that, and then last month I mentioned that we're moving here, but I do plan to continue to run the meetings remotely for as long as that is happening, and then I'm also in charge of taking care of the website and booking presenters and things like that. But Lloyd will probably be the local guy, and then I'm sure he'll be asking around anybody else that would be able to assist and being able to make the in-person meetings happen. So do support him in that. I am in this coming week, I'm starting another series of kids robotics classes using this Make Block Ranger kit. So I do have information on my Facebook page, and then you can also, anybody that's interested can email me. I'm targeting primarily 10 to 13-year-olds. Seems to be a good age for kind of getting kids started with this sort of thing. It's just a sophisticated enough kit that it's a challenge for them, but it's probably a little too simplistic for older kids. But my class is really geared to the beginner, and the first 6 sessions went quite well. Kids had a great time, and so I'm looking forward to starting another session. Let's see. There's a variety of robot events, and I see Chaz is online, so I'm gonna, when I get to the spot here, I'd be interested to hear how the PopCan challenge went there. I'm sorry I was not able to listen in on that, but anyway, I'll ask some questions about that when we get there. There's also in the slides here, there's various events across the country that you can check out. Let's see. We are probably let me see here. Next in-person event. We'll go to the next one here. So at our last Robothon committee meeting, we talked about the next Robo Magellan event, and right now we're looking at probably sometime in May. That's at least the plan. So we will be continuing to kind of talk about that meeting and discuss the logistics of that. We also would love to do another virtual event, as long as there's enough, we get 3, 4, 5 people that are interested in giving a talk on some robotic related topic. We could certainly pull that together. Those are pretty easy to set up and arrange, so we would like to do that. I am interested, though, in hearing about the SRS PopCan Challenge. You want to chat about that, Chaz?
Yeah, it sounds great. Good morning, everybody, or whatever your time zone is. So we had a great PopCan Challenge turnout, I think. I mean, it was 4 robots that showed up, 3 ran. The venue was really nice. It was 3rd place Commons. We ended up moving it kind of last minute because Greg secured us a better space. It was more open anyways. And it lended to a lot more people that wouldn't naturally come and see the robotics to be there, because there was just a bunch of people there. And to this big open space and a whole bunch of people that like sit down and sit there. So that was in Lake Forest Park, I think it is, in there anyways. So we had a run. John's Robo came, got 1st place. It was he had a great first run, and his robot was running pretty well. The 2nd place was Dave's Auto Dave, that robot that looks like an RC truck and makes a lot of cute noises. Mm-hmm. Think he got tied down with talking to kids most of the time. So, and then 3rd place was Greg's Gidget. Yeah, so it went out real well. Mine was dead on arrival. Unfortunately, I had some problems with my 4-wheel steering, so didn't run, but that's all right. Now I get to work on it a little bit more. So we had a fun event. There was a lot of people there. And yeah, we'll probably use that venue again next time, probably sometime, mid next year. I haven't decided on it yet.
Was the event was recorded?
Yeah, it was recorded. I ran the Zoom the whole time. I have not edited it. Sorry. I just got to trim it up a little bit. I want to pull there's some kids in it early that I want to pull out before we actually did the practice even. So I want to pull that portion out because, I didn't ask their parents if they could be in it. So got to trim that out, but I'll get that on YouTube and I'll share that link off to you so we can post it for viewing.
Yeah, we'd love to. We can post it on the SRS website and the Robothon website, and so yeah, cool.
Sounds great. All right.
Yeah. Thank you.
Yeah, absolutely. Thank you.
All right. Okay, back to. All right, let's see. Are there any other events of note that anybody wants to mention out there? Where things coming up? If not, I will move on. Okay. Online presenters. Robert Kellogg has been really good. He just keeps feeding them to me, so I've got a bunch more queries out there. I have to get on the Gmail calendar for the SRS and load the new ones in. So I maybe try to do that either today or tomorrow, so that when the calendar cycles past the current event, then when you look at the calendar coming up, you'll see all the ones coming. So I have presenters. I don't have a presenter set up for January, but all the way through, I believe, till May or June. So pretty much half of next year is booked. So that's really cool. And got some more possibilities kind of floating around out there. So but if you come up with anything, either you meet somebody that you think would be interesting, feel free to forward their contact information to me. If you would like to present yourself on something, just reach out to me. I will be more than happy to arrange for that. So anything, any way you can help me to fill the slots is awesome. I know this is I think the presentations are a valuable and interesting part of these meetings, and so I want to keep loading them up with folks that you guys want to see. And so here's what I have currently open. I think possibly Donna Smith might do something in January. So if she does something in January, you'll see we're booked all the way until June with a variety of them. So anyway, we'll see. I'm hopeful. And then next month, I'm going to lead a facilitated discussion on telemedicine and remote patient monitoring technologies and that sort of thing. So I hope there'll be plenty of you to join in with that. I'm going to just kind of provide feeders for the questions, kind of maybe possibly little short video clips, things like that. Sometimes it's hard to find a really short video clip. So we might just kind of throw out questions and topics, and then we'll just have the back and forth discussion about things and collect links that you guys might be aware of. And as with most of these kinds of things, we could go on for hours talking about any one of these subjects. And so it's the idea is just to give us a little bit of a interaction amongst our group on various topics. So, and if anybody else would like to lead a facilitated discussion on a topic of their choice, let me know. That's an easy one. Love to just slide you into any slot that's open. And so keep that in mind. It's pretty easy and doesn't really require a lot of preparation on your part, mainly just some stimulating questions and ideas, and then turn it loose and see what happens. So just in case you're kind of wondering about ideas, here's some things. that we could talk about. Some of them we have touched upon, some of them not. There's always, some of these things, the technology is always moving. So even if we've had a discussion within the last year, there's chances are that there's changes and things that have happened. So there's always new things to talk about and share about. So let's see. A little bit later, we have Ricardo Tellez, who will be talking to us about the construct, and this is pretty cool. We've had a number of presenters on ROS over the last year or so, and this is essentially a tutorial website on ROS, learning ROS, and doing robot programming with it, and it's pretty amazing. It has both real and paid content. So, and there's self-study as well as instructor led. So it's a kind of a very wide, comprehensive thing. And so I'm looking forward to hearing from Ricardo about this. And after the meeting, I may not be able to hang around too long, but I probably hang around for a bit for our post-meeting discussions. I'll turn the recording off at that point, but we can just hang on here. I might have to pass the host baton to somebody else there. I've got my grandnephews are coming over, and they're going to help us move boxes. And I never turn down help moving boxes, So we moved 250 of them from Washington into this house, and I've gotten rid of probably 100 so far, maybe 120 of them so far, but there's still a lot of boxes here. So still kind of right now we're kind of playing Tetris, shuffling the boxes around, trying to figure out how we can make them fit. And at this point, we just need to start getting rid of stuff. So that's kind of on our agenda. So with that, I am going to open the floor to whoever has something that they would like to share, and I'm going to turn it loose, and whoever's got something that they would. Come on, Shirley.
I'll share a bit. So I'll go with lessons learned maybe a little bit from this last PopCan challenge, but I think it would relate to any of the competition robotics. So when we were setting up, it's a lot of work to bring everything in, and we did a lot of work this year. I think Terry was there to help out and a bunch of others, and with the arena, I rebuilt the arena to be 4-foot sections just because it was a lot easier to move in and out. But the robots themselves, when you build a 35-pound robot, it can be a challenge to move it. When we were at Third Place Commons, it wasn't too bad because we were parked outside, but it's still a challenge to move that robot, and then all the other stuff that you bring around, right? Power supplies, extension cords, battery chargers, everything. And Greg has that big Gidget, right? And you're just like holding the thing in. A dolly doesn't seem to work very well. He did have a dolly, but I decided, when we're building these robots, Seattle Civic Center is even worse because you're usually parking like 3-4 blocks away, right? And again, still you're bringing in 100+ pounds of things. So I decided to make my robot a little bit more move friendly. Like, actually, you have to make that a consideration. If it's just sitting at home, it's not that big of a deal because it's just sitting on the ground. But then you don't realize when you're carrying this. It's 35 pounds, but it's still weight. So I decided, not only that, but weight takes its toll. And I found, and one of the reasons I really couldn't run is because I have this 3D printed 4-wheel steering mechanism, and it was holding up pretty well just sitting at home. But when you start moving things around, I didn't make the prints robust enough, and I was starting to get cracks and breaks where my bearings were. I'll give you an example. So I have, this is a rebuilt piece, but I do put bearings in all of my 3D printed parts. so that when it's, metal on metal, it actually has something to be robust. But this now is, I don't know, that's probably 10 or 12, a 12 millimeter plate. But the old one was 6. And that thing, by the time I got it sat down in the arena area, I had noticed that all of the top bearing blocks had cracked open. And that was really disappointing, of course. And then the entire mechanism itself, there was quite a lot of wear and tear. So in true spirit, I'm rebuilding my robot because I do that every year. So I have substantially larger 4-wheel steering servo-driven robotics, and I'll pull this here out. And I made it a little bit more, replaced it on the fly friendly. So now the old ones again were like, yeah, I think 8 millimeters tall, and these ones are substantially, they're 20 millimeters. So it's all 3D printed mechanisms, but it's chunky enough that I don't think I'll have problems with it this time. So if you are building a competition robot, I recommend think about not just building it at home, but the whole moving process, and all the way down to like printing handholds now. So I have something to carry it with.
Brilliant.
So when I'm bringing it in. So that's my 2 cents on that. It's kind of a lesson learned from this PopCan challenge.
Chaz, with the parts that cracked, would it, is it helpful to use a different type of 3D printed material like PETG or something that's, more rubbery, more flexible, less crackable?
Yeah, ABS, PETG, whatever. Yeah, absolutely it would have. But I think I just didn't build it robust enough. I think no matter what it was, I mean, maybe if it was polycarb or something like that, it would have held up. But because the robots aren't incredibly strained or constrained by their proportions, you can go 2 foot by 2 foot, you can just build them bigger, right? And then the PLA is cheap, it's readily accessible, and I run 6 printers at home right now, and I stick to the same brand because then I don't have to mess with my slicing settings so much. I just know Overture brand, and I know like I can leave my settings alone and just hit print and walk away, and it works out. I mean, I'm rocking 6 printers right now at home, just printing pieces like this. So yeah, you're right that if you were really stuck with something small, or I could have, found somebody that did some milling for me. There's a couple people at the makerspace that do it on the side, and I did actually have one gentleman, Chris, actually create aluminum stepper holders for the 4-wheel steering portion that actually slips through these portions, so it holds the stepper motor, because the stepper drive motor and wheel assembly is all aluminum, and he machined that for me because I didn't want that to be a 3D printed part. But
nice. Yeah. I was thinking, I mentioned in the chat, but it was just direct to you, but it seems to me every once in a while I've seen people with the large beach picnic type gear carts for transporting stuff, and that seems like a nice option for being able to move a lot of stuff, when you're trying to bring things in, with the the big wheels to get over weird terrain. That way you can haul stuff from the car into the arena more easily.
Yeah, that's definitely one solution other than carrying, for sure.
Yeah.
And that would have worked out just fine where we were at last time, as well. But it's a good one. It's one of those things you don't realize you need it until you're there.
Yeah.
You think about all the different tools you might need and glues and all that spare parts, you're throwing that all in bins. Mitch had asked in chat what percent of infill I'm using. Normally I run at 20%, but I ran 35% for all these kinds of parts.
You also mentioned a makerspace. Which one do you use around here?
Oh, I'm sitting in it right now. I'm at the Snowco makerspace in South Everett.
Okay.
Yeah, I ran into the same problem with PLA, and so I ended up going to 50% infill, and that seemed to make a lot of difference.
Yeah, it is surprising when you're looking at them print the difference between 20 and 30%. Like I wouldn't think it made that much difference, but you can tell just by, mine print hexagons inside here, but whatever the thing is, like how much tighter the little hexagons are when you increase it just a bit. That's a lot of printing though, right? I mean, you have to weigh how much time is it going to print all those things. And I mean, if it's some really critical parts, maybe it's worth it.
Yeah, I've had some 8-hour prints that,
Yeah.
Yeah.
So the base of it, the blue piece there, that's a 34-hour print. So,
yeah.
and I mean that's a time consideration. Like, how patient are you?
And which printer are you using again, Chaz?
I have 3 Ender 3s. One's an S1 or S Pro 1 V2. I can't remember what that's called. 3 are just Ender, or the 2 are Ender 3 V2s, and then 2 Ender 6s, and an Ender 5. But my wife uses most of the time. I ended up having one, and then she stole it, and she prints a bunch of stuff for craft. So I just keep buying them, and she steals them. Now I've settled. I have an Ender 3 Pro S or whatever it's called. It's a higher temp one, and then and a regular standard 3 V2.
So on the subject of 3D printing and different filaments, I realized something. If you look at like construction, like home construction or industrial construction, and think about materials that are really brittle. Cement, concrete, is really brittle. It has a strong compression strength, but it's very stiff and it's very brittle. And what do you do to, strengthen that? You put rebar in it, right? So you put down the rebar and then they pour cement around it. So if you take PLA, which is famously brittle, right, but actually does have very strong compression strength, and you don't use the PLA as the strength, use the PLA as the scaffolding to hold together something that's structural. So then if you go back and you look at the Dexter 1 robot arm, it's printed out of PLA, but the entire structural part of the robot is carbon fiber strakes and steel rods, and the stepper motor bodies are part of the structure, and it's all held together with epoxy. So the PLA printed parts are only there as a scaffolding to hold the strakes and the motors and the steel and whatever else while the epoxy dries. So you print the parts, you squirt a bunch of epoxy into it, you shove the strakes in there, you let everything harden up, and then you end up with a bot that's, I've dropped it off a table and had, accidentally fell off of a 3-foot tall, standard table, and watch everybody go, oh my God, that's the end of that, and then picked it back up again, set it on the table, and went to work on it. And because, it hit the outside of the PLA, and the PLA transferred through compression as opposed to shear or tension, that impact through into the steel, carbon fiber, whatever else frame inside, it was zero damage. So that's just thinking about how material works in construction. If you want to make something that's very stiff and very strong, then you need to use that kind of a method. And then if you're making something that's like, if you 3D print in ABS or in this nylon, or a lot of the carbon fibers are actually using one of the carbon fibers is using nylon, but it's actually a very flexible material, right? So what you get out of that is quote strong, end quote, but what that means is it flexes, right? The reason why it's quote strong, or why people think it's strong, is because you can't break it. But the reason why you can't break it is because it's bending, right? So that's not stiff. That's a different, all these words have specific meanings, and you have to really dig into them. So that's one of the things that I would love to see people do more, is like use multiple materials and 3D print things with like holes in them and then put threaded rods through and tighten them up. So like if you look at the original RepRap printers, and people, have that's kind of fallen out of fashion, I guess. But if you look at the RepRap printers, they use threaded rods, bolts, and washers. And then those went through a 3D printed part. And the 3D printed part was then compressed between the two bolts, which made it stronger. Now they still had shear strength or shear issues because they would have one 3D printed rod going past another 3D printed rod in a PLA printed part. And so it was the PLA that was holding the two together, right? But one of the things I've always thought would be like a really cool thing to do is to come up with, if you had some kind of a system where you had two nuts that were like tack welded to each other or something like that, and then one threaded rod goes through one of the nuts and the other threaded rod goes through the other nut at an angle, right? That would be a much stronger way of building stuff. Anyway, just thought I'd share that.
You could probably use JB weld and you wouldn't have to actually do metal welding to adhere those together, because that's a metal bond.
Great idea. And that comes up with like, you 3D print the PLA part, you put the two threaded rods in there, and then you inject JB weld into it and let that, the PLA holds everything in position. So you get that alignment, right, is correct. And then the JB weld is not messy anymore, which is what if I work with epoxy, I get it everywhere. And then let it set up inside. Yeah, that's a great idea.
So my little presenter ears perked up here. This sounds like be a really great topic for somebody to present on. Talk about this, because James, what you're pointing out, it's like when you're printing something, and you have to think about the structure that holds it up while it's being printed. Even you can't. I mean, as your structure is being built, it has to have sort of scaffolding to keep it from collapsing until it's complete. And that's a piece. And then what you're talking about here, where you're trying to make something that has a lot of the good structural properties that you're looking for. It's got good shear strength. It's not going to if you can put things in compression loading, that a lot of times that's a good helpful thing. And there's it's like you kind of need to be a mechanical engineer, I guess, to be able to, because you got to kind of think about all of these bits and pieces. It's not just a matter of create a shape in the computer, feed it to the printer, and hey, everything is going to be lovely. Because how much plastic have people wasted trying to make something and not knowing what they're doing, and it either falls apart while it's being printed, or they get it all done, they take it out, and then as soon as they try to do something with it, it breaks, because it's we didn't think about the loads and the stresses, and where are the stress points on this thing, and the concentration points, and I would love to
tell you the mechanical engineers that I've worked with. So I don't know exactly why this happened, but I ended up with the impression that mechanical engineers are kind of dumb, like mechanical, right? And let me tell you, it was so wrong. I've worked with a number of mechanical engineers, and they are literally some of the most intelligent people I have ever worked with. Fantastic programmers, just smart as heck. And you know why? It's because in order to get a mechanical engineering degree, you have to think about all of the physics and everything that you just said. Like building a mechanical structure is so much harder than people think it is. There's so much into this. And okay, all right. You've triggered a rant. I'm sorry, but this is so there's this thing about replacement of technologies, right? Like you go back in history, and like when we first started doing computing, it was mechanical computing, right? Like the guy figured out how to compute when the tide was coming in, which is a really complicated computing problem. And he did it with a mechanical computer. If you get a chance to look it up, how tides are calculated, absolutely brilliant, bunch of pulleys and stuff. And then as soon as like electronics came along and it was analog electronics, all the mechanical computers got thrown out because they were starting to, all of the calculators and the registers and all that kind of stuff, they were all mechanical. And then analog came along and they threw out all the mechanical stuff and everybody went with analog computing. And then digital computing came along and they threw out all the analog computing and they went with only digital. And now it's all like neural nets, right? So if it doesn't use a neural net, why are you even talking about it? Okay, like it. And so there's this thing that we do where we just throw away everything from the past whenever a new technology comes along, and people forget that like if you have the capability of making a micro machine, MIMS technology or something like that, you can make a mechanical computer that's every bit as powerful as the full-size digital computers, right? If you can do analog, there's an analog circuit that will give you a low resolution but very, very fast first estimate on a square root. No digital circuit can do that. So you can use this analog circuit to give you, and then you use the Newtonian method to walk on the square root with your digital circuit, right? But is there in any CPU's floating point unit, is there an analog circuit to give you the first seed for a square root calculation? No. It's like, why do we forget all of the old things when we start to do the new things? And so the thing to do is like go to your local woodworking shop and watch people use hand tools. I mean, there's such an education in that, and look at how furniture gets put together. You want to build a good, strong robot? Look at furniture. Look at hand woodworking. Look at that kind of stuff, and then look at mechanical computers, and look at analog circuitry, and look at digital circuitry, and then try to convince some kid that he doesn't need to learn about neural networks to the exclusion of all else, and then just sigh and give up. Thank you for attending my rant. I now return you to regularly scheduled program already.
No, that you're right. It is, there's much to be learned from the past. I mean, there's some people that say, no, you always got to be looking to the future, always looking to the future. But you know what? You should at least look over your shoulder now and then, and because you will avoid making mistakes when you look back now and then, and just kind of remember, oh yeah, and you're right. It's craftsman. It's a lost art, really. I mean, it's a kind of a dying art. I mean, people that can do these kinds of things with your hands. 3D printers have made it so easy to create things, with a computer, but there's a lot to be said for creating things with your hands. And
I dropped a link in chat to a video talking about this company that's making use, or I don't know if there were ever analog CPUs back when, but they're designing and making analog CPUs now to do some of the calculations that James was talking about. And the guy who made the video worked with the company that I linked below, or who are the ones doing it. I'm not sure what exactly they're trying to do with it, but I think just make it available to see what's possible with them.
I remember back when I was first in school, and the first computers we used were analog computers doing differential equation solutions for control problems. Analog computers did that very well. Digital computers have a nice thing in that they're easier to change.
Mm-hmm.
Mm-hmm. There was
if you're doing,
go ahead.
If you're doing the same calculation just with different inputs over and over, analogs are kind of the way to go for it.
There was I'm trying to think of probably a dozen years ago or so. There was a thing called it was very popular at the time, called PSOC, PSOC, Programmable System on a Chip. And
Cypress,
it,
absolutely love them.
Cypress
yeah,
Microsystems.
yeah, and there was the it seems like it was a kind of a little bit of the idea of being able to, you have basic building blocks on your chip, and then you can sort of pick and choose how these things get put together to accomplish what you wanted. And I'm thinking that it had both analog and digital processing capabilities built into those building blocks.
And
Yeah.
digital
Those are,
logic blocks as well. PSOC 4 and PSOC 6. I don't remember ever using the 5s, but the 4s were what I got started with. The cool thing about that is for $10, you can get a PSOC 4 system on chip with the debugger, not just the programmer, but the debugger on the printed circuit board, and you plug it into your PC and start programming. The only reason why I moved away from them is because they, at least at the time, it's been a year or two since I've looked, the only IDE, or the only way to program the thing, was through a Windows only IDE, and I moved to Linux and will not go back. So I was kind of done with them. If they ever come out with a Linux compatible one, I will jump right back on that. But yeah.
Yeah.
So Nathan, you worked on the mixed signal chip design team. And I'm curious about because I never really got into the analog side of it, but like connecting the analog parts together, like can that really be done without introducing like distortions or whatever?
Well, it's not. You might be able to get better results with discrete parts in many cases, but I think the value there is you have like programmably controllable. It's controllable analog, right? It's programmable, and it's really easy for people to go build a system on a single chip, and then so if you want to make something really compact, that's really where the value from PSOC comes from.
So you can prototype something. This is how I always thought about it, is you can prototype something like instantly, and then if it isn't quite good enough, but you can see that you're getting, close, then you go ahead and break it out into discrete analog components and maybe, upcycle to a little bit better. Because the thing with analog is it works fantastic in the computing realm for low resolution, super fast, and then ultra low power.
So one of the key examples where PSOC was used in an actual product is, I believe, it was the first generation large screen touchscreens that were in the Tesla vehicles were controlled by a PSOC 3 part. So the part was qualified for automotive, and it wasn't intended to be a touchscreen controller, but the part had such capability on it from a digital and analog perspective that it was turned into this large form factor touchscreen controller. And before that, you had to have several chips to be a large touchscreen controller. There simply wasn't a chip on the market that could do the large screens. And so it was a pretty big deal at the time.
Interesting.
And our application engineers did a superb job, building the firmware to run on that. So.
You guys remember the iPods, right? That's what PSOC, one of the biggest products that they were originally in the beginning. I had two friends that I went to college with who graduated from SPU, and they were they got jobs working for Cypress many years ago.
The PSOC chips are also in Sonicare toothbrushes, or at least the early ones. I don't know if they still are, but
that I didn't know. Interesting. But I want to point out one of the other beauties of the PSOCs is the fact that you've got a graphical programming environment for being able to wire up your design, where you're not writing all the code in code, but also they used to have a fantastic presentation format, so that once you were done with your project, it would give you a full color poster of the design and give you great presentation output that you could use to demonstrate what you've designed. And we used it that was one of the reasons why we used it in our senior design projects at Seattle Pacific University when it was really young. I did that back in 2004, 2005. And so I was super impressed with that piece of it, that they were very
That it's
thoughtful.
self-documenting.
Say again, I'm sorry.
That it's like self-documenting, or is that the value that you're talking about, or are you
Yeah.
talking about the pride of being able to hold up something and say, this is what we did?
No, it's in our college senior design projects, you had to be able to present your design at the end of the year, and so we were able to make large full color posters of our designs. It was all integrated in the software that you used to design with.
Right.
And
yeah. So it's like
wasn't
self-documenting, right? I mean, it's like
Yeah.
you get to the end and the documentation is like there because you can see the whole like layout of it.
Yeah, and it's really nice. It was full color design. It was really sexy, which I just was super impressed with, because a lot of times at the time, in order to do something like that, you'd have to export everything out into Visio or something else and do a whole set of graphic design, to document your projects, and you can the PSOC software is all self-contained, which is pretty cool. And then they moved it forward later with, I don't know if they're still doing this, but PSOC Creator, so that there's less requirement for you to work with hardware and be a software programmer at the same time. You can do a lot of this without programming the code with pre-configured code modules, which is just gives you a chance to get stuff done faster, especially when you're just doing prototyping. Anyway, they've got a fun, robust group of products that are still out there, including ones for radio controlled things called PROCs as well.
Yeah. Now, if they just start supporting a real operating system, I'd be right back on.
Oh.
Sorry, I shouldn't start religious wars on a video meeting.
I didn't realize that I was bringing up such a controversial topic there, so.
Yeah, it's I got a story about a life-changing meeting that I couldn't present at because my Windows 8 laptop decided to do an update, and that was it. that was the end of Windows for me.
Yeah.
At least you didn't bring up battery technology, Steve.
Battery technologies?
That used to be our, the topic you don't bring up at meetings because it goes on for hours.
Oh yes.
Well, LIFO isn't really all that safe, and no, sorry.
Oh boy. I think I agreed to do a presentation on battery technology, if I'm not mistaken. So maybe I should resend that.
No, don't let. We'll just permanently mute James so he can't shoot arrows at you. So.
We had to fly staff down to California to give a battery technology talk on ultracapacitors versus lead acid cells.
Just remember to wear your PPE.
Yeah.
Yes.
Oh yeah, we haven't even gotten into IDEs yet, or editors.
Oh my goodness, yeah.
Oh, and then space versus tab. Such fun. All right.
Yes.
All right.
Yeah.
We shouldn't go there.
Right. My son, he just got himself you guys familiar with the Framework laptop? It's supposedly a very maintainable, fixable, upgradable platform. Have you guys heard of that thing?
Yeah,
it's pretty cool.
Everything's USB-C and PCIe as plug-in modules.
You've got these 4 ports. Let's see here, get my hands so you can see them. Yep. Nah. So there's 4 ports on the thing where you can just pull out, you can plug in, USB, USB-A, USB-C, HDMI, display port, all these different types of you got 4 ports. You can have a bag of accessories and you just plug in whatever it is you need. And then he says you can upgrade the motherboard, you can replace the keyboard, you can replace the display. I mean, the whole thing is kind of made to be taken apart. Uses the same size of screws throughout, so you only need one screwdriving tool, and it's not a weird one that requires some special proprietary thing. But he says what shifted him over that way. He'd been a kind of an IBM ThinkPad guy for years, because those things they're pretty bulletproof. And he says he got a new battery for this thing, and the batteries are smart. And of course, these stupid thing. It wouldn't. The computer wouldn't talk to the battery. This is a Lenovo computer. It wouldn't talk to the battery because the battery didn't recognize the battery, because they changed the firmware somewhere in there. And so now, and he says he went all over the web looking for ways around this. Somebody had done a hack, hoping to find somebody done a hack to allow the battery to be able to function with this laptop. And he finally just gave up because everybody was saying, yeah, can't be done. And you talk about battery technology and then you get companies that go and do that, where they go and they make it so that the battery has to be able to talk to the computer in order to charge properly. I'm just like, what is that?
What was the name of that again, Steve?
The computer framework.
Yeah.
Just look up framework laptop. It's really a cool thing. I had not heard of it before, but I was looking at it and he was showing me his. They're about $1,000. Start about around $1,000, and so it's kind of a middle of the road price range for a laptop, but it just sounds like maybe somebody has finally succeeded in making that holy grail of laptops, where it's something that you can buy one of these things and you can hang on to it for a while and not worry about the thing becoming obsolete in a very unreasonably short amount of time, because. Although I'm not sure if it'll run. Well, I suppose you could probably run Linux on the thing, make it into a real computer. So.
Does anybody remember lunchbox computers?
Lunchbox.
They used to make, when they started making, what was it called? ATX Mini motherboards, the ones that were relatively small, and then they would put them in
Mini ITX.
Yeah. They would put them in these huge metal cases that were double the size of the motherboard. And somebody went, hey, you know what? We could make a little case that's just the size of that motherboard. And then it could be a kind of a semi-portable computer. So they came up with these things called a lunchbox computer. It was the size of a large lunchbox. You put a handle on the top, and it was like taking a console TV and putting a handle on the top and calling it a portable, right? But it had a little spot in the front where the keyboard would snap into place over the top of the screen, and then the whole thing was closed up and you could walk away with it. And then you unlatch the keyboard, it would come down, and there was a little cord that would pull out. You had a separate keyboard, and then the LCD screen would kind of pull forward a little bit to get a good angle. And the cool thing about it is it would take your standard ISA plug-in cards and upgraded motherboards, and so you could just put in a new upgraded motherboard when you want. You put in whatever ISA cards you wanted. You weren't limited the way you are with a laptop. I love those things. They fell out of fashion. I still have my old one sitting in a closet somewhere, 386 with black and white EGA graphic screen. But anyway, just reminded me of that.
Yeah, I mean, most of that's moved to the Dell micro form factor, 9055 series or whatever they are now.
Yeah, they're pretty small. We just got a couple of those at work.
Yeah, it's like, and you
They're
pick
amazing.
them up. You pick them up like the 5-year-old models off Amazon or eBay. They're like $150. You get a 8th gen core processor, and it's a little box.
What is it called?
A little bit bigger than a
Micro
CD.
PC.
Yeah, micro form factor. They're like really ubiquitous in like call centers.
Oh, these
small offices.
optiplex things. Yeah.
Yeah, it's
Yeah.
like you bolt them to the back of your monitor, and
Yeah. What's amazing is they had the latest one we saw. They had like 5 or 7 video outputs. It was
Right.
stunning the amount of video that they could support for their size. They're really, really small. They're
Yeah.
smaller than the Mac Mini in form factor and footprint.
Yeah.
But they're a little taller than the Mini in height. But yeah, it's impressive. It's first PC I'd seen that sort of rivaled that form factor, and it looks like they're trying to do competitive video with it, like what the Mac Studio is doing.
Yep.
Looks
But
like
it's
Lenovo
a lot
has
cheaper
one.
than the Mac Studio, though.
Right. And you can buy the 5-year-old models. You know, we buy them for like our factories in China. It's like it's so much easier to just buy 4 of them and go, well, I don't care if 2 of them fail in China and I can't go replace them because they're another $100 to buy an old model.
Looks like Lenovo makes a ThinkCenter M600 in
Yep.
the same
Very similar form factor. The Dell has a little more third-party support. You got all the human-centric support and whatnot for little brackets and whatnot to bolt it to the walls or bolt it behind things.
Yeah, this thing has, I'm looking at the Lenovo, and this thing has 2 HDMI ports on the back of it right out of the box.
Yeah, and it should have Thunderbolt as well for USB-C.
Oh,
so you can put another 3 on USB-C.
It does. You're absolutely right. That's pretty wild. I'll have to look at that. I'm looking at this one is 8 gigabytes with a 512 gigabyte SSD, and it's $130.
Yep. Yeah, they're amazing. It's like you want, and they're pretty low power. It's like, if you're not trying to do AI processing, you could probably run it off a battery. It's just a 20-volt power supply.
Well, wait a minute. If it won't run a neural network, then it's useless. Why are we even talking about it?
Well, you could. It'd just be 100 watts. You just have to budget your batteries for that.
Hey, last little dig at neural networks. And just to be clear, I think neural networks are great. They're wonderful for the problems that they solve. But it leaked recently, and it's been verified that Boston Dynamics, all their mobility, all the stuff that their robots do, it's computed. None of that is learned. In other words, that's not neural networks that's owning those robots. That's physics and math and control loops.
Yeah.
So, a lot of people were kind of blown away by that. And I'm like, nope, that's how you do it.
No, we found that out probably, 3-4 years ago, I thought. At least that's when I heard about it.
Oh, well, I'm probably just late to the game, but I just love that. I mean, that's, old school. Let's do it.
One last one for the
when you
small
see
ones.
the robots doing flips, then it gives you a lot of respect for some of those control algorithms.
If you're looking at more of the small little desk side computer things for your internet stuff, and you're looking at Lenovo, I don't think they make it anymore, but you'll find them on eBay and Amazon for sure. They had an IoT. Lenovo makes an IoT version of that same computer. It's completely fanless, has real serial ports on it. It's just designed for, if you're doing SCADA sort of water monitoring or industrial applications. So you can just drop it off in the middle of nowhere and leave it out there for 6 or 7 years.
Cool. Wow.
I remember quite a few years ago, we were building processors and circuit cards that had to fit in a can full of batteries and go sit on the ocean floor for 5 years. So ultra low power. That was an interesting problem, especially when you're trying to do FFTs.
Wow.
So FFTs, on the ocean floor, I wonder what they were listening for.
Not what you would think. This was
Nord
the
Stream.
offshore commercial oil drilling business.
Oh, okay. All right. There was a Veritasium just did a video FFTs, and he talked a little bit about submarine hunting, which is
Yeah,
what
I was thinking seismic anomalies. So
yeah, and then seismic anomalies. The video primarily was about detecting nuclear explosions.
let's see. Well, I'm hopeful that our presenter is going to show up. I don't see him online yet, so we can continue our discussions here for the time being. This sunset behind me was that was about a week and a half ago or so. You know, it's just like, oh, fills my soul.
Yeah. Yeah, you got a beautiful area, and you're in a red state.
I know. It's yeah. Well, I could just tell, you know, when we crossed the border, it was like there was a change in the hue, you know, of the
Wait a minute, we've now hit on IDEs, operating systems, politics. Are we going to go into religion yet?
Hey, why not? You know, it's just,
Hey, you want to talk about something really frustrating? Try Ross.
well, you know, that was actually the intent of our discussion today. Has anybody visited the website, the Construct Sim? If you haven't gone, you can set up a free account on there to go out and access the thing. It's so our presenter, Ricardo, he's the guy that started that kind of, he initiated that and set it all up and everything. And I mean, it's amazingly extensive. I mean, there's just tons of stuff all across the whole Ross universe, you know, and it's it's an impressive website. You know, regardless of what you think about Ross, it's like that you got to admire the just, you know, the magnitude of what he put together there. So it's
what I admire is the fact that he actually got it to work.
Yeah.
That's the definition of a backhanded compliment right there.
Yeah.
I have been on their website. It's pretty darn cool, and they have a lot of really good videos. Now, you know, most of those are like an intro or a taste, and then they want you to sign up for the class. But you know, what the heck? They got to make a living, and I think what they're teaching is worth paying for. So,
right.
I mean, if you're going to do Ross, I mean, you know, that would not be my choice. But I'm saying if you're, you know, if you need what Ross is given, then you know, paying somebody to learn it is not the worst choice in the world if you can afford it.
No, it's not unreasonable. I mean, you know, it's So anyway, so
it's a pretty steep learning curve to get up to speed on, Ross, I'll tell you.
It's kind of the impression I get too. Yeah. Let's see here. Let me I'm gonna just jump back to share my screen here for the moment. Just kind of these are details I usually forget to cover these things out. And of course, now it's going to take forever to get up there. Come on, squirrels, run faster. It really is coming too, believe me. Well, anyway, I'll start. So let's see. We'll maybe take a break shortly, but the same Zoom link next month, as you guys are probably very familiar with now. The recording will be, you know, I'll work on over the next couple of days or so. I'll get the recordings posted up on YouTube, and so if you want to go back and rewatch anything, and you know, they'll be available there. And then the chat. So please feed anything that we've been talking about that hasn't already been fed into the chat. Get it in there, and that'll get posted along with the rest of the meeting stuff. And you know, presenters, obviously, always looking for those. And any kind of feedback for the meetings, Seattle Robotics Society at Gmail. And boy, that is just, that's weird. It was, oh, there we go. Gee, good grief. That really took a long time. And let's see, I think the next one is just a black slide. So I'm going to back up here. I've been kind of carrying these videos along with me here for a while. I thought I might, let's see, I might just show maybe one of these guys and see what yeah, so this is a combination. It's an article that talks about this ferro, let's see, what was it, what did I call it? It was a
ferrofluid.
Ferrofluidic, yeah, ferrofluidic. And okay, let me get back to it there. Yeah, oops, where did my, there it is. Ferrofluidic. And let me see here. A soft robot. And let me see here if I can make, oh yeah, that's got a bunch of, let's see. Ferrofluids are giving superpower to soft robots. That's a pretty bold statement, huh? All right, let me see here.
You might want to change it to optimize for frame rate.
Let's see, how do
I think it's a
let's
zoom
see.
option
Oh, I
somewhere.
got it.
It'd be a zoom option.
Let's see.
I think you can
I don't know what you're
optimize
talking
for.
about. That's not creepy at all.
Let's see here. I'm looking for yeah. Let's see. Settings. Let's see. Video. Turn off. Use hardware acceleration. Turn off my video. Wonder if I get that option. I'm doing this on a Chromebook, so it's the browser version. I might not have as many options as you get. I will okay, what I'm gonna do at least here, I know you probably wanna okay. There, I just posted the link to this video in the chat there, so you can watch that locally. Probably get a little better a better view. I'll just go ahead and for now I'll just go ahead and play this so you can. Let me see here. I will do one thing that might help. Let's try this. So anyway, I thought that was pretty cool. I know that if the sound seemed a little bit weird, I slowed down the playback on it, so that did seem to look like it made what you guys could see a little bit less jerky. But go ahead, feel free to watch the video in real time if you like, there from the link in the chat. But there was some pretty interesting applications out there, and the hands were pretty remarkable. I wonder how much grip strength that they can get out of those things.
Those inflatable silicone ones were really interesting. There's a lot of variety in those.
Yeah. Yeah. That always lots of just lots of interesting little bits and pieces. That Robert sends me stuff like that as well. So that was one of those videos that just was like an interesting video he came across. So thought I'd share that with you guys.
Yeah, that was really cool. What I was impressed with was watching that one soft robot that was navigating the channel between two pieces of wood, how they managed to make it turn the corner, from well below the entrance hole. What was really fascinating, because I can't quite picture how they're mechanically getting it just by filling a bladder with air, how they're getting it to do those sharp corners.
So I think with those, what they do is it's a predetermined path where they put tape around it. There was a Veritasium video actually talking about inflatable robots like that, and and I think there's some that are controllable, but they're not as small as that one. But if you have a rough idea of the path, then you can add tape on certain sides, and that'll essentially hold it in place while the rest of it continues to expand, and that'll cause it to turn.
Okay. I did see, I mean, you could see on a number of them, they had a metallic strip inside. That makes me wonder if that's some kind of
I think that might be like Kapton tape or something.
Oh, is that all it was? I was thinking maybe it was a sensor tape, where you could determine the length and the reach of the robot by the distance measured by it being uncoiled. But it was orangish, so maybe it was just capped on. It didn't matter.
Yeah, I just dropped the Veritasium video in chat there.
Oh,
there are a few different ones he goes across. The first one that shows up is an interesting one where it has triangles of inflatable material, and there's motors that essentially, I don't know, like move the side lengths around for it to kind of like flop around.
Yes, it's interesting. People are kind of getting, they're really starting to kind of think outside of the box with some of this stuff, doing these very unconventional things. And it's kind of fascinating to see what people are coming up with. It's just like, there's stuff you might never have even thought about doing with one of these things. And it's like, and then they're finding, sometimes you find really interesting potential applications with this stuff.
My name's Tom.
Yeah, that was, let's see, Randy. Well, I don't know. I am not seeing any sign of our presenter online there, so I might have to rebook him. He was, when I originally contacted him, he's actually based in Barcelona, and the time zone difference between here and Barcelona is actually not bad. It's just in the evening there. I think he's 8 hours ahead of us. But then I just recently got an email from him saying, "Oh, but I'm actually in Japan," and that concerned me a little bit because our meeting times here land in the middle of the night in Japan. You may recall last, earlier, let's see, when was that? I think it was early in the year we had a Japanese presenter, but we ended up having an afternoon meeting so that his time presentation was, within reason. But when I contacted Ricardo, he said he would do it, even though he was in Japan. And I was like, well, stupid cat. I see my cat over across this. The street in front of us is pretty busy, and then blasted cat. Naturally he's got to go wander over there. Anyway, so it's entirely possible that he may not make it. So, because I am concerned, because it's like I think it's a 16-hour time difference. So it's actually Monday, or excuse me, Sunday, his time in where he's located. So we may not have a presenter this month because of that. That's unfortunately, but I will be sure to get him back.
We could continue the battery argument.
Yeah, that sounded like a great topic there. And I speaking of batteries, I have a Nissan Leaf, a 2019 Nissan Leaf, and I had to get it from Federal Way, Washington, over here to Idaho. Practically to Boise, and anybody who's done a road trip in a non-Tesla electric vehicle knows that it's an adventure. I mean, it's always an adventure because the charging infrastructure for non-Teslas is nowhere near as reliably robust as it is for Tesla. So, crossing the country on a Tesla, I mean, people go thousands of miles and road trips on those things all the time. And it's like, it's no big deal. There's superchargers on all the major freeways and highways and stuff. The other the non-Tesla, us non-Tesla owners, it can be a little more dicey.
What's the range on the Leaf?
It's 220 miles. So it's got the 62 kilowatt battery, the biggest battery that Nissan puts in their cars, in their Leafs. And so, it's not bad. And there's, like ABRP, a Better Route Planner, is actually a pretty good app for planning stuff. It gave me some reasonable stopping points. I discovered that there's a free fast charger up at the top of Snoqualmie Pass. So if anybody who's been up there, there's a Washington State Highway rest stop building. There's a kind of it's a big A-frame building that's kind of one end at the west summit. But if you go about 2 blocks or so beyond it, there's a little gas station there, and right next to the gas station is let's see, what do they call it? West Coast Electric Highway charger, and it turns out it's a CHAdeMO. It's a Leaf fast charger. It doesn't even have a CCS plug on it. It's only got a Leaf connector on it. It's the craziest thing. And it was no cost to use it. It was like, I was just kind of astounded. I mean, I didn't even realize it was there. It showed up on ABRP though. So I said, well, I got to go check that out. And climbing to a pass in an electric car is definitely, you take a big hit on your range going up there. But because of the regen, you pick up you pick up quite a bit coming back down the other side, and I did. So, but I went ahead and plugged into the thing while I was there, and there was a little coffee shop, so I went and got myself some coffee, and just kind of hung around for about an hour while I juiced up, and and it was fine. I did this over 2 days, so I stopped in Kennewick for the night at a hotel that had a destination charger, and I was able to fill the car up overnight there. And then I had to make another stop in Island City, LeGrand, at a Walmart, because Walmarts, it turns out, have a lot of Walmarts have these quick chargers available. So I was able to make it no problem, really. I mean, it was I don't know that I would want to come back, do the reverse of that, because it is a little, like I say, it's a little more iffy with a non-Tesla, but it was okay. And I like that there's a certain kind of there's a certain adventure to it. It's not like when you take a road trip in a gas car, you don't think about whether there's gas stations where you're going, unless you're going way out in the middle of nowhere, and then you probably better think about it. But for the most part, when you're just kind of traveling to tourist destinations, you don't really need to worry about that. There's gas stations everywhere. But with electric car, it's a little bit more iffy. And
back to the Wild West a little bit for
a little bit of that
time.
I love electric cars, and and I'm not a greenie weenie. I mean, I didn't buy it to save the planet. I'm sorry, I didn't buy it for that. I bought it because it's so much fun to drive. I always wanted one, and it's a kick to drive. I love driving it, and it's like, I don't really care whether I'm saving the planet or not. I'm just having a good time.
Are you going to get yourself a little portable gas generator to stick in the side of the trunk in order to be safe?
Yeah, I was thinking about that. That just sounds like a great idea, just to kind of blow your, sort of do the raspberry at the EnviroNazi crowd, No, I'm not. I'm probably not going to go there. Though I did see some guy did that with a Tesla. Took the rear window out of his Tesla, his Model 3, and he had a gas generator back there, and he was using that instead of plugging in. You know, I mean, this guy was a YouTuber. You know, I mean, he did it. He did it just for the publicity of it, not because it was any practical reason whatsoever to do it. And especially with a Tesla, it's like, well, it's ridiculous. Why in the world would you do such a thing? But it was pretty amusing.
Guy on YouTube who put a V8 engine in a Tesla Model S.
Yeah, I heard about that. I didn't watch the video. Did you see the video, Randy?
I saw he was showing to somebody, but his name's Rich Rebuilds. That's his channel.
Okay. Now, okay, so he's surely he just did that for the publicity, just to get people to watch his YouTube video, right? I mean, because that's like, wow, why would you do that?
So the question I would have is, did he retain the motors to power the vehicle? In other words, did he hook the V8 to a generator, or did he actually put a whole drivetrain in there?
Do you have any idea, Randy?
It was a complete. Basically, he put a Model S chassis on top of a Corvette drivetrain.
Okay. So the undercarriage was actually the Corvette then, not a. So okay.
Because it might be interesting to do, like the diesel electric trains, right? So you just drop an engine in there that runs some sort of generator.
Yeah.
That's called the Chevy Bolt.
Yeah. There was, I don't know if you, as some of you guys might be old enough to remember, there was a popular science article from way back where a research lab went and put a jet turbine engine on a car chassis connected to a generator, and then so they generated power. It was electric drive in the car, but it used the gas turbine generating power, just basically like a locomotive. It was exactly the way a diesel locomotives work. And as I recall, the control system for the motor was super simple, because if they stomped on the accelerator, they could burn rubber with this thing. So it didn't have any kind of torque feedback that would stop the motors from spinning hard enough to actually break traction with the ground. And then of course they would, as they were driving this thing around, you hear this scream of this jet turbine engine on the back of this car. And needless to say, it was more of a research project, because it was way too noisy to be a typical a regular vehicle. But I remember just kind of being intrigued by the idea, and it's like, that's kind of cool, because you can tune the engine to run the generator at a kind of an optimal fuel consumption, power generation speed. And then if you had some, put some batteries on board, and I think they did have some batteries, but not very many, but a few batteries to provide a kind of a buffer. So for acceleration and things like that, then the car would draw power from the batteries along with the generated power. But then once the car was moving at a more stable speed, the power demand was low enough that generator would then actually charge those batteries and power the car along. So I had no idea what kind of mileage it got, but.
Makes me want to see a jet powered train now.
Now that would be awesome.
So did you guys see Simone, the crappy robot lady?
Oh yeah, Simone Geertz.
YouTube? She made a Tesla pickup truck from a Tesla car, which turned out to be quite the undertaking.
Wow.
She drove it out to the unveiling of the Tesla Cybertruck, and apparently there was some very complex reactions from the Tesla marketing people there about wait, what do we do? Wait, do we feature this? Do we not mention it? Do we mention it but then not show it? You know, do we tell her that she can come or she can't come in, or you know, it was just the part that was the funniest for me was watching corporate people try to figure out how to deal with a maker, you know, who has gone and done something that they didn't.
I don't know if this is going to be the smartest.
Okay, I think I found her video here, so let me post it into the chat. Simone Gertz, is that how you say it?
You know, I heard her name pronounced once, and I found out that I've been pronouncing it wrong. So it's a humdinger the way that her name is actually pronounced.
Okay. So it looks like it's about a half an hour video. So, but it looks that just sounds like fun. And she sounds like our kind of people too. You know, do something crazy like this. It's like, yeah.
Well, she got her makers start making robots.
Ah.
Well, a specific genre of robots.
A very specific genre of robots.
But there's children present, so I won't use the word. But basically, it's robots that didn't work super well. Put it that way.
Yeah.
But what's great about that is that, you know, I mean, another one of my favorite rants is about people getting tied down by not willing to do things poorly, right? Like everybody wants to do the best job of something. And a lot of times that gets in the way of the best thing ever happening because there's this like perfectionism that just messes everybody up. And so it's a really good thing to just make a really bad, you know, robot. And then the key is that you learn from that and iterate on it and build a slightly less bad robot, and you know, you keep getting better and better and better slowly, as opposed to like trying to be perfect the first time you do it. You know, it's like thinking that you're going to sing opera the first time you open your mouth in, you know, a choir or something. Just start and expect that you're going to be terrible at it and then get better later. And that's what she's done. You know, like she does some pretty cool builds, some stuff that really, you know, works. But a lot of times they start off with her just doing something that's like, okay, well, that didn't work. And then she starts over and does something else. You know, I love that about her. I think that's what's really wonderful.
Yeah, what's the scary thing is, though, that one of her new projects is to build a fusion reactor.
You know, fusion power is at most 5 years away and has been for the past 50.
Yeah.
I work right across the street from the new fusion energy company in Everett that it just finished their building this last year. There was a big groundbreaking ceremony and stuff for it. The governor came out for it. They're right across the street from Fluke. Well, our Fluke location, which is not the location most people think of, because I'm working customer service, so it's a little out of the way.
I still like my 77A.
Ah, yes, good meter.
Have y'all heard of Hebocon?
No.
It's started in Japan, but it's essentially crappy robot competition. And they have very, very simple rules. I think a lot of them are kind of like sumo-esque, but you have to make, you know, some sort of robot, and it fights other robots, and you get less points the more complex the robot is. So like the bare minimum simple, just most mediocre thing you can do is the best way to do it. We ran one at my makerspace in college, and the winner was a Tupperware filled with rocks, because nothing could knock it off of the fighting area.
And they would have gotten less points if you'd used Tupperware filled with lead shot.
I think so, yeah, because I mean, you can just find rocks wherever. Yeah, I remember
love
reading
that.
it.
I love
It's a lot of fun, and it's a great way to get really anyone into it. I was reading a
Yeah.
story that in Japan they had a competition, and one of the people took the train over and then forgot their robot on the train, and so just went and got a beer instead, and they got a trophy for it.
Just for buying a beer.
Well, they did such a crappy job that they forgot their robot and then went to get a beer instead.
So you've heard of participation trophies. That was a non-participation trophy.
Yeah, a giving up trophy.
There was a mini sumo that had no propulsion. All it did, of course, it had to fit within the form factor before it started. But then at when the bout started, what it would do is cover up the white line at the edge of the sumo field. It let down a piece of black plastic. As a result, the opponent wouldn't detect the edge, and so would just drive itself off this rope. I don't know how. I don't remember.
Toro.
I love that.
Steve, do you remember that robot?
I do, yeah. And
I don't remember how well it did.
Yeah, because it was all, I think it was all black, and I think that was I think Tom Dickens built that thing, and he took it down to San Francisco, and there at the time there was this big beefy robot down there that was just clobbering everybody. I mean, it was really dumb. There was not a processor on it. It just had the sensors to look at the floor and basically look down, and so it would just kind of bounce off of the white line around the edge of the ring. And so the risk, of course, was that this thing would actually hit the robot itself. But then because there's no limit on the height of a sumo robot, so Tom had these very tall wings that would flop down, and then they were kind of curved, so they covered up a large section of the white line around the edge, and the robot would just sit there. And I think it did have to move enough to get these wings to flop, and that was it. That's all it did. It just kind of shook itself a little bit, and then these wings would flop down, and then it would just sit there. And it actually did beat that robot, because that dumb robot would just sit there, and it was kind of bouncing off the lines, and then it just eventually it went past him and drove itself off the side. Obviously, now if it were to come in and hit him directly, it would push him off, and then he would lose. But he figured that the risk was worth it, and it was really actually a very clever strategy. And I'm thinking that they might have changed the rules a little bit, because I think your robot has to move every so often during the course of the bout. So I don't remember whether it's like every 30 seconds or something. So your robot actually can't just sit there. It literally has to move a little bit. So, but it was a very clever strategy for a rope, because there was no way to physically overcome this San Francisco the San Francisco company or group's robot, because it was just too big and heavy and strong. So it was you had to find a smart way around it, and it was a very clever solution.
It reminds me of a video I saw, some of the Japanese sumo, the really fast sumo robots, where they had a match, and there were two low profile wedge shaped sumos that were using these really fast motors, and they would start out, once they started the match, the two robots would flinch to get a sense for where the other robot was. And the robot that won was programmed to back up and move away from the other robot as soon as it started in its direction, and the other robot just went flying out of the ring because it just backed up, and it just went, wow. It was spectacular. But I was really amazed, though, the refs in the normal sumo there, they have to wear hockey gear to protect themselves, because the robots, when they hit each other, parts go flying everywhere. They're so fast.
How big are the regular sumo robots?
There's different classes.
3
what
kilogram is the normal one.
the mini?
Wow.
Yeah, but
Mini's
they have
like 100 gram.
yeah, they have they also have one, don't they have 1 kilogram and 3 kilogram?
1 kilogram, yeah.
Also, yeah, those are not considered mini class though, right?
No,
But-
those are
Yeah, these were
Yeah.
actually, they might have been a little large for mini. I don't think they were 100 gram.
right.
They were larger than that.
Yeah, when you get up to the 3 kilogram, you're starting to get up to a weight where you can put substantial motors and batteries in these things, and and so you can, Bill Harrison could tell lots of stories about some of this stuff, because he got into the ones where you put the magnets on them. So these robots could actually, I mean, you could defy gravity with these things. You know, you could have a ring that was on the wall or even on the ceiling, and the robots could actually drive on these things. But when you think about, magnets holding the robots down, imagine trying to push two robots pushing against each other, both of them being held down by magnets. And they would get very aggressive. And as you say, the kinetic kill strategy became very popular. So the robots would launch themselves at each other at the fastest possible speed, because the only way they could hope to beat the other guy was to literally smash him hard enough that he comes loose and flies out of the ring. It was beyond pushing. You couldn't do pushing anymore. And I think in Japan they still have competitions that are like that, and they're quite violent. Yeah, like you say, you gotta, they put up they put up shields around the rings, because the parts that go flying and the robots that go flying could hurt somebody.
Yeah. Yeah, the match I was watching, the guy had shin guards and almost like an umpire's gear on, and a face mask. Yeah. It was impressive.
Love it. Yeah. Oh, the good old days. We haven't had the larger sumo competitions at Robothon for a while. I know it's quite a bit more work to build the bigger robots. More work, more money to build those things. But you can definitely have some pretty impressive matches when you get robots where they're big enough that you can put like drill motors, for example, in them for the drive systems and stuff like that, and you can have batteries that can deliver tens of amps to the motors, and
wow.
Yeah, you sometimes get the magic smoke leaving the robots from they get to pushing each other, and they just sit there and they go like this, and all of a sudden whoever is the most robust electrically is liable to be the winner, because somebody's going to start smoking. Well, any other I don't think we're going to have our presenter today, unfortunately. So any other burning topics there anybody wants to throw out there? We're so about 15 minutes left, or we can
just real quick, I'll mention I posted it in the chat earlier, but I went to the Hackaday SuperCon a couple weeks back there, and they had the coolest badge, which is a 4-bit computer with a front panel. So if anybody is into computing history, you know, there's a front panel there that is just freaking amazing. It allows you to, you know, have that experience of like coding in binary opcodes and actually writing a program, which I'm old enough that, well, I started actually on an 1802 and I thought it was really fancy because it had a hexadecimal keypad. You know, we thought that was like, you know, high tech.
Yeah.
But soon after that, I actually ended up with an old S100 computer that had the toggle switch front panel. It was a knockoff called an Olson S100, and so I have actually as a kid had the experience of toggling in a bootloader program so that I could read stuff off of cassette tape, you know, into memory. Anyway, the upshot of it is that, you know, you do that, and I mean, you're interacting with the digital logic, you know, right down there at the floor. And what's cool about this badge is that when you put in the opcode, there's like a list printed on the board of the opcode names with a little LED next to each one. So the 4 switches that you're toggling bits on and off in are then called out as one of 16 LEDs that comes on that indicates which opcode you selected, right? And then there's 2 more 4-bit sections for the first and second operands of that opcode. And it is just, it's such an experience programming that thing. And then the little LED array in the upper right hand, or on the right hand side there, that's data memory, which there's 16 pages of 16 pages. No, is that right? Yeah, 16 pages of 16 nibbles. So what the display actually shows there is 2 pages. The right hand 4 columns are the first page, and then the next 4 columns to the left of that are the next page. And there's a little register that you can change that indicates which page is getting displayed. So like, for example, you can tell it the page to if you set the page register to like 3, it'll show on the right hand side, it'll show page 3, and then on the left hand side it'll show page 4. So you get this 8-bit wide display of the 4-bit memory. So the opcode's down at the bottom. You see how there's 4 sets of 4. So it's a 12-bit instruction, and there's 4,000 instructions in each in RAM where you can run. And then that whole section in the on the, well, not all the way to the left, but the section that's most of the way to the left in the upper part, that's the ALU. So you're actually looking at like you know, OR gates and AND gates and, you know, whatever else that's in the ALU. And you can, as you execute the instructions, you know, you can see the ALU doing the computation.
Wow.
All the way on the left is instruction decode, the stack pointer. It has 3 bits for the stack, but there's only 5 levels because the stack uses page 1 of RAM. And so there's only room because each stack, each memory address takes up 3 nibbles of that one page, so you only get 5 levels of stack before it overflows. And then there's like the flags, you know, 0 overflow and negative, I think, if I remember correctly. And then on the lower left-hand corner, those little switches control the mode. So you can put it in like a run mode. You can put it in program mode where you're entering a program. You can put it in single step mode where you're pushing a button for it to sequence through the instructions. And then there's a dir mode, which allows you to save your program into one of 16 double EEPROM slots, which are indicated over on the display. So the whole processor is not actually made through digital logic. It's actually all emulated on a PIC microcontroller, which is on the back of the board. And there's a couple of AA batteries back there, so everybody walks around the super conference with their badge running. And if you're cool, right, then you've programmed in some little animation or something on your badge to, show people that you actually figured out how to program it. And they had put out all the information about the badge before the event. So, people wrote like assemblers. And there's a guy who's even working on a language. It's like, let A equals B, let, B equals plus equals 6. It's like that level of language, but if A greater than 3, then, that kind of thing. But it was a wonderful little trip through retro for me and for some of the older farts that were there. And it was a fantastic introduction for kids and for the younger generation and the not so much younger generation, people who are not quite as old as I am, to actually interacting directly on a bit level and being able to kind of understand what's happening. So check out some of the videos about it. One guy, a friend of mine, actually built a punch card reader for it. And so it was you had the little paper printouts, and you could fill in the holes with a Sharpie, right? And then he would pull it through the reader, and it would load the program in there. Another guy, I don't know if this is going to make any sense, but what is it? Rock Band, is that the name of the game? The one where you see the little
guitar game.
Well, it's the ones where you see the little things floating up the screen, and then you're supposed to hit that note, or like for a piano, you're supposed to.
Yeah, Rock Band or Guitar Hero.
There you could tell. Okay, so it was that, all right, but for programming the badge. So you would literally load in your program into this quote video game, and then it would show these little dots floating up, and when they hit the buttons on the badge, which was at the top of the screen, then you were supposed to press the buttons on the badge to actually enter the program. It was so stupid and so hilarious. They had a badge hacking competition at the end. I think he either won it or he got one of the higher scores. There was all kinds of ridiculous stuff. One guy, actually, he and his friend came from some other country, and they had these little add-on boards that would go on the top of the badge there, where you see that connector in the upper right-hand corner. And they built a Wi-Fi radio link to go between two badges with ESP32s. And then they wrote a program that actually was running on the badge where you could play Pong. So you could play Pong against the other guy's badge over the wireless radio link. Or if you were right next to the other person, you could. They had a cable. You just run a cable between the two badges, and you could play Pong from one guy to the next.
Oh, wow!
So, pretty.
Do you know
go ahead.
Do you know if they released the Gerber files for that yet?
There is a GitHub repo for it, and I think they have all of the files. I know that the source code for it is released. Not actually certain whether or not the rest of it has been released. But if you can afford it, if you ever want to come down to San Diego, or not to San Diego, it's actually in Pasadena. You really should consider spending the money to come and visit Hackaday. It is absolutely a once in a lifetime experience. I strongly recommend it. I'm trying to find the GitHub repo for it, but I haven't been able to. And by the way, that if you look through the Hackaday Prize winners, just some really amazing stuff. A lot of stuff for power generation. As a matter of fact, Steve, you'll be happy to hear that 2 of the winning entries were specifically made with in mind the idea of people driving electric cars and running out of power. So, for example, there were 2 of them that were both wind generation systems. One of them was a very nice little small wind generator that you could pull out and expand the blades out, and then set it up on a little pole that collapsed down, and you would put a battery pack up on there, and then run it. And then the idea is you could charge your phone and make a call if you were completely out of power. And then the other one was a kite turbine, which is really hard to do because the kite lines get all messed up. This guy came up with a pretty good solution to that, where he was using like hula hoops flying in the sky and transmitting the power down from one hoop to the next hoop. So he had like, I don't know, 10 or 20 hoops coming down to a bicycle generator down at the bottom. And then his idea was that you could, charge something up and then eventually be ready to move on again. So
Incredible.
yeah. There was also, I think there was 2 or 3 of the winning entries had to do with reusing plastic. So one of them was a really easy system for using PETG like soda bottles and turning it into filament. Another one was a really huge 3D printer, a cable bot, which excited me, with a really big extruder that could use chopped up plastic directly, which I thought was pretty cool. And then there was another one, which was a really professional extruder for filament for using, waste plastic or whatever to make filament with.
The cable bot you're referring to, is that a climber or something else?
No, it was a 3D printer, but like a very large format 3D printer with a huge extruder. So they were like, the idea here was you would like 3D print, furniture or.
Like kind of like a Delta.
But with cables. Yeah, exactly that.
Okay, I got you.
Yeah, tension as opposed to compression.
Yeah.
Which I've always thought made more sense in a Delta. I have this whole rant about like, why don't we do cable bots? And there's a 3D printer called the Sky Delta and another one called Arcus 3D, which are just brilliant 3D printers. Sky Delta 3D printer. You'll have to, because there's like Sky Delta is a ton of other things. There you go. Scroll down a little bit. Introducing Sky Delta. You see it down there, the GitHub link and all that kind of stuff. The RepRap link is probably the best one. Flying Sky Delta RepRap 3D printing. And then the other one is on Hackaday, I think. And it's called the Arcus, if I remember correctly. Arcus C3. I may be wrong about that. Darren Swecki is the guy's name. He has a bunch of cool projects actually, so I'll just post a link to Darren there in the thing. It's called the ARCUS. Arcus ARCUS-3D-C1, the cable 3D printer. Here's the exact link to it. That is that one is amazing. So the key point with this is that it reduces the mass of the things that need to move to the absolute limit, right? That's as little mass as you can possibly have by having a cable, right? And then you just have, all you have is basically a hot end floating in the air with a Bowden cable going to it, and you're shoving filament into it, and the thing just screams. It's so fast, tremendously accurate. And the big problem that he has is the only reason why he couldn't go faster is because he couldn't extrude fast enough. So he was caught in that standard dilemma of going with a larger diameter extruder, or of having to slow down. So what he did was he built an extruder for it. Actually, another one of his projects on there, where he built a hot end rather, that actually had 3 hot ends, all feeding one nozzle. And that was the only way to, get enough. And then he has a version of the Arcus, which was for pick and place. So instead of a hot end head, he had, the other head, the vacuum head. Dude is an absolute genius. And interestingly enough, sharing all of these things with the world instead of making money off of them. So nobody thinks that his stuff is worth anything, which I always think is really sad, but also an interesting commentary on humanity. If somebody gives something away, it must be useless. And this guy is just like turning the world on its ear, but because there's no dollar signs behind it, nobody's really interested.
Yes, that is a sad commentary.
Sorry, that went south quickly.
That's capitalism.
Yeah, if you get a chance, just look through the guy's projects and just look at like all the amazing stuff that he's actually pulled off. And he has these videos, very poorly produced, kind of fragmented videos where he goes through all of this stuff. Having said all of that, it is 12, and I am going to go for a drive with my wife.
Yeah, I'm thinking it's about time to wrap things up here. This has been great, though. I'm glad you guys you kept things going in spite of my presenter not showing up. But, we've had some good discussions here. It's I've enjoyed this. So I think
probably call you when he wakes up.
Yeah, I know. He may not have realized what time 11 a.m. Pacific time is in Japan. So I'm thinking.
Could he have shown up yesterday?
Yeah, maybe so.
Yeah.
Well, I will definitely get him back. So it'll be a while now, or maybe he'll be able to. We'll see what happens in January. I don't have a for sure firm one for January yet, so maybe I can slide him in there if I don't find somebody else. So. Okay. Well, anyway, this has been great. I got window coverings. You can see I'm probably looking pretty washed out to you guys because the sun is shining right in my face here. I've got there's window coverings that are coming for these windows. I'm sitting by a window that's about, I think this is a 4 by 8 foot picture window. It's huge, but there's no coverings of any kind on it. So I don't have any way to tone it down. So I'm looking forward to being able to sort of close it off and, make myself a little bit more visible. But anyway, I love the sunshine though. I'm loving that a lot. So. Anyway, thank you all for showing up. Thank you for joining in the discussion. This has been great fun, and look forward to seeing you guys next month. And with that, I will go ahead and stop recording.